Hello 8th graders. In section 2.5, we're actually covering a lot of what we already covered in our proofs video that you watched a couple weeks ago. So a lot of this we're going to skip over and we're just going to do some problems as you've done most of this. So let's first review. You do not need to write this down, but we need to review the properties of equality. Now, you guys have been doing a great job at the first few here. Addition, property of equality, subtraction, multiplication, division. You've already done these, you've already used them. Now, as review, reflexive property of equality says that something is equal to itself. Now, something that you will probably use on week 2's proofs that are due next week is the symmetric property of equality. If you, for example, have A equals B, you can say B equals A by this property. So if you solve an equation and you get, for example, 10 equals x, and you have to solve for x, you then have to write that as x equals 10 by using the symmetric property of equality. Our first example is found on page 105. So while you do not need to write down the actual problem, you do need to write down the work. This problem involves the motion of an object in a computer game. So to simulate the motion of an object in a computer game, the designer uses the formula SR equals 3.6p to find the number of pixels the object must travel during each second of animation. In the formula, S is the desired speed of the object in kilometers per hour. R is the scale of the pixels per meter, and P is the number of pixels traveled per second. The graphics in a game are based on a scale of 6 pixels per meter. The designer wants to simulate a vehicle moving at 75 kilometers per hour. How many pixels must the vehicle travel each second? Solve the equation for P and justify each step. So the first thing I'm going to do is make sure we have some room here. So I'm going to make this smaller, and then I'm going to move this up. So the first step is to write down the equation. SR equals 3.6p. And the reason is because it's given. The next step is plugging in what we know. Well, we know that S stands for the desired speed of the object in kilometers per hour. Well, it says that the speed is 75 kilometers per hour, so we plug that in. 75 times R, and R represents the scale of pixels per meter, and the scale is 6, and that equals 3.6p. And what did we use? We use substitution property of equality, or you can just write substitution. The next step, 75 times 6 is 450, equals 3.6p. What did we do there? We simplified. Step 4 is dividing both sides by 3.6, which gives us 125 equals p. And step 4, for the reason, would be the division property of equality. Now this is the step that you might have not done before. Step 5, we still have to find p, so we have to write p equals 125, and we can label that pixels. Now what did we use to flip it around? We used the symmetric property of equality. In example 2, I want you to write down the actual problem and the picture. And then next to each one, I want you to write down the justification for each step. So write down the reason next to each step on your own and pause the video. If you did it correctly, the first thing you would have written down would be the segment addition postulate. The next thing we did was substitution. Then we simplified, or combined like terms. Then we used the subtraction property of equality by subtracting the 3x. We then added 4 to both sides, so that'd be the addition property of equality, and the division property of equality is what we did in the last step to obtain our answer of x equals 3. This part is new. In Chapter 1, you learned that segments with equal lengths are congruent and that angles with equal measures are congruent. So the reflexive, symmetric, and transitive properties of equality also work for the properties of congruence. So properties of congruence, here's what they state. The reflexive property of congruence says that figure A would be congruent to itself. As an example, you could say a segment is congruent to itself by using the reflexive property of congruency. Now, symmetric property of congruence is the same type of thing. Instead of saying figure A is equal to B and B is equal to A, we can say figure A is congruent to figure B, then figure B is congruent to figure A. So this would look like, as an example, that angle 1 is congruent to angle 2. We could then say angle 2 is congruent to angle 1 by using the symmetric property of congruence. And the transitive property. We could say if segment PQ is congruent to segment RS and segment RS is congruent to segment TU, then we can say that segment PQ is congruent to segment TU. That is the transitive property of congruence. Please note that we use segment and angle symbols. We do not use the measure of anything, and we're not talking about the length. We're actually talking about the segments. In our last example, we wanted to identify the property that justifies each step. So look at A. The measure of angle 1 equals the measure of angle 1. What property is that? It's the reflective property of what? It's of equality. The reflexive property of equality. In B, what says that segment XY is congruent to segment VW, so that segment VW is congruent to segment XY? That would be symmetric property of congruence. And C, angle ABC is congruent to angle ABC. That would be the reflexive property of congruence. And lastly, angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So we know that angle 1 and angle 3 are congruent. That's the transitive property of congruence. The only vocab word in this section that you would know is proof, and you already wrote that down in your vocab from a couple weeks ago.